Okay, looking at parallel lines and finding the equation for that. When we have parallel lines, they have the same gradient. So that's something that we can work out straight away when we have the question, is we can work out the gradient of the other line based on what our first line is. Then we can solve for C. So generally we will be given a point that lies on that line so that we're able to solve for C. We might also be told what the y-intercept is, and that makes it even easier to do. So our example that we've got here is a line parallel to y equals negative 2x plus 5. So to start with, I want to see what my gradient is for that line, and it's going to be negative 2. So I know straight away that my gradient for my new line is also going to be negative 2. Then I've been told that it passes through 4, 5. So that's my coordinate that I'm going to use to solve for C. So I'll write y equals mx plus c. I'm going to put in the things I know. So I have a y value of 5. I have my gradient of negative 2. I'm going to multiply that by my x value of 4 and then add c. So I get negative 2 times 4 is negative 8. I've got 5 over here, and I need to add something to negative 8 that's going to give me 5. So obviously I'm going to need at least 8 and then an extra 5 to get up to, so negative 8. So add 8 will get me to 0 and then extra 5 to get me up to 5. So my C is going to be 13. The other way you can work that out is just to do 5 plus 8. Once I've got those two values, I now have my m value, I have my c value, so I can write y equals mx plus c, and I can put those values in. Negative 2x plus 13 is my equation of my line. In my next video, I'm going to go through how to work out the equation of a line if they are perpendicular to each other rather than parallel.